Okay, done, done. So when you're reading problems, it's really important for you to be able to visualize what you're reading. So based on what you guys have learned so far, if you started reading this problem and you're like, well, 2 electrons, you're most likely picturing 2 circles with a negative sign in them. And that'd be fine. And then you go on to read a problem and you read the problem and it says separated by a distance of 6 times 10 to the 6 times 10 to the negative 3 meters. If you're having problems visualizing it, please let me know. It's very important. And so what are my knowns here? Oh, oh. That's correct. I'll wait for someone to let me know publicly. Yeah, your radius, right? R is 6 times 10 to the negative 3 meters. What else do we know? Yes, that is correct. Well, yeah, one question. So I give you a hint, right? These electrons are electrically charged. Well, what's the charge of each electron, right? So these electrons are Q1 and Q2. Considering 12 of you did this homework, I'm surprised more people are not giving me the answer. Q1 is negative 1.6, right? Negative. It's an electron. It's an electron. It's negatively charged. So both Q1 and Q2 are both 1.6 times 10 to the negative 19 coulombs. What else do you know? Or rather, what else are you trying to find out? What are you trying to find out here? Fe, yeah, you're trying to find out what your electrostatic force is, right? Think about it. These 2 electrons don't want to be near each other. They want to get as far away from each other as possible. Right? These electrons do not want to be near each other. Like they're basically exhibiting a force. They're forcing the other electron to get away from them. Think of someone you hate, right? You don't want to be near that guy. You want to get as far away from that person you hate as possible. You don't want to sit near him, right? That person could be me. Right? You want to get as far away from me as possible, right? There's an electrostatic force here. All right, so you're trying to find out what Fe is, right? So Fe, the formula for Fe is K Q1 Q2 over R squared. All right, so K is something you know, right? It's given to you. I'm gonna round it to 9 times 10 to the 9. Q1 is negative 1.6 times 10 to the negative 19. Q2 is negative 1.6 times 10 to the negative 19. R squared. So I'm gonna diverge from yesterday. So I thought about it a little bit. I realized that what I taught you yesterday was kind of like too hard for you guys because you guys aren't used to that type of math. What I'm gonna do, I'm gonna show you what I'm gonna do. what we're gonna do is we're gonna isolate the top part. We're gonna multiply the top part first on a calculator. All right, so this is gonna be step number 1. We're gonna multiply the top part in a calculator. So we're gonna do 9 times 10 to the 10 to the 9 times negative 1.6 times 10 to the negative 19 times negative 1.6 times 10 to the negative 19. And so when you multiply that entire top part, we get 2.3 times 10 to the negative 28. And now what we're going to do is we're going to do the bottom. We're going to square that bottom number. And it's something really important. You should put in parentheses there. 6 times 10 to the negative 3. Close that parentheses, squared. And what you get is 0.0000036. And now you continue on with your math, right? So you're going to do 2.3 times 10, 2.3 times 10 to the negative 28. Well, put a parentheses around this. Divided by 0.00036. That is not the correct answer. This is the correct answer, okay. And that's an easier way to do it, right? You're basically just plugging it into a calculator, right? Just plug it into a calculator. But the fear I have, right? The biggest fear that I have is that you're going to get the order of operations wrong. While this does seem simpler than yesterday's method, I 100% feel like you guys will get the order of operations incorrect. You don't understand. Can you tell me where you started losing? You started getting confused? What about it? Are you confused about the squared part? How did I simplify the square? Or so the square root, so this is basically what I entered in a calculator. I'm gonna be doing I do parentheses 6 times 10 to the negative 3, close my parentheses, and I'm gonna square that. You gotta go and pick up your little brother? Sure. Are you okay with, because I don't quite understand what you mean by simplify. All I did was I plugged it into a calculator. So you just square root this number right here. I mean, not square root, you square it. Yeah, that's all you do. How did I get 2.3? I multiplied the top part. The part where I boxed in pink, I multiplied that entire top part and I got 2.3. If you find it easier to add the exponents, then do it. Then do it by all means. Do it however you want. But I'm doing it, you can do it both ways. You got 23.04. What is your exponent? Okay, so okay, I got what you did. You did 9 times 1.6 times 1.6. And you got 23.04. Sure. But when you do that, when you get 23.04, your exponents are going to be You get 23.04. Your exponents are going to be 10 to the 9, -19, -10, -29. But then if you move the decimal place over one time, you add 1, and you get 2.3 times 10 to the -28. You okay? You understand why you got 23.04 now? Okay, cool. Yeah, you guys can do it however you want, right? You can do it for the exponents. If you want to separate your exponents, it's fine. If you want to do it for a calculator, that's fine as well. Are there any questions about this? Please let me know. Please raise your hand. One of the math teachers told me that you don't learn multiplying exponents uh, until algebra 2. Is Q always the same? Q is not the same. Q is your electric charge. If you have 2 electrons, your Q is not going to be 1.6. No, I mean, what I mean by that is that if you have 2 electrons in a certain point, your charge here is going to be negative 3.2 times 10 to the -19. Oh, algebra 1? I don't know, guys. I really don't remember. I don't recall. High school is a blur. For me, personally. I think it's because I hit my head like sometime around in college. I just lost like most of my memories in high school. All right. All right, let's move on. Let's move on. Come on, guys. Knowns. Let's go. Let's go. Let's go. R is equal to 3. Good. R is equal to 3 meters. Both Q's. Q1. Oh, I'm loving the participation. I'm loving it. This is like, it is, this has to be ultimate feeling. Like as a teacher, when you see someone actually answering your question, that's like, that's bliss right there. All right, that's charge number 1. So the charge of this metal sphere. So you have a metal sphere that's positively charged, right? It's positively charged. And Q2 is Q2 is -4 times 10 to the -6 coulombs. So which means like sphere 2 is like negatively charged, right? So as a lot of electrons. Well, I mean, there's more protons than electrons here. And they're separated by a distance of 3 meters. And what are you trying to find out? I've never used yellow. Yeah, you're trying to find out what electrostatic force is. Now I understand why I never use yellow. Yellow on a white background is not doesn't look too clear. Yellow on a black background though, it looks pretty clear. So you're gonna plug in your formula, right? So Fe is K Q1 Q2 R squared. K is always 9 times 10 to the 9. Q1 is 6 positive 6 times 10 to the negative 6. Q2 is negative 4 times 10 to the negative 6. R squared, 3 squared. So you're going to do the same exact thing. You guys are going to multiply the top half. You're going to multiply the top half, right? You're going to do, on a calculator, you're going to do 9 times 10 to the 9 times 6 times 10 to the negative 6 times negative 4 times 10 to the negative 6. That does not look right. Oh, no, it's fine. That's fine. So you get negative 0.0216. Hopefully you don't need a calculator for 3 squared, but just in case you do, which is fine, right? 3 squared is 9. 3 squared is 9. And this becomes what am I doing? Negative 0.24. And if I were to simplify this, I'm moving my decimal to the right, which means I'm subtracting an exponent of negative 2. So this becomes negative 2.4 times 10 to the negative 2 newtons.
Do you always need to simplify it?
Your answer choice is going to be an exponential form.
Okay.
So it's not like, do you need to simplify? It's basically your multiple choice answer will be in scientific notation. So I guess the answer is yes, you must simplify it. So yeah, I guess the answer is yes. Can I go over number 2 again? Sure, I'm assuming this is, you mean question number 2 is this question, or do you mean like this question over here? On Go Formative or? Okay, I'll go over number 2 again. Just give me a second. Any questions about this current question, question number 4? When I have time, can I go over number 3? Sure. I want to go over this simulation though. So can someone tell me if these spheres are positively charged or negatively charged? Negative. Yeah, you see on the bottom, negative charge, negative charges. Okay, so I want you guys to tell me what happens as you bring, what happens to your force? What happens to that electrostatic repulsion, right? Because they're 2 electrons, so they repel each other. What happens to this force as you get closer and closer and closer? What happens to an electrostatic force? It increases, yeah. You can tell. You can just tell by looking at the number. What happens if you increase the distance between these 2 charges?
It decreases.
Decreases, okay. Are these 2 charged objects going to attract or repel?
Attract.
Why? You're
Because
correct.
when it gets closer, the numbers, they like, they go at the same rate.
That wouldn't be the reason why. They're opposites, yes. It's because it's a positively charged object and a negatively charged object, which means they must attract. They are opposite charges, which means they must attract. So as you bring these two objects together, the force of attraction increases. And likewise, as you increase the distance, the force of attraction also decreases as you increase the distance, right? So keep this in mind because this is an answer to one of your homework questions. So we're gonna go to number 3 because I'm gonna go to number 3 because I can easily bring back the work from number 3. I'll go over number 2, even though you asked me first. It's just more convenient for me to go over number 3 first. So sorry, whoever messaged me privately about number 2. Yeah, it's just much easier for me to like bring back. Okay. So number 3. So number 3 says that there are 2 electrons. So there are 2 electrons, right? And they're separated by distance, which I've drawn here, right? So these are the 2 electrons, these are the 2 charges, and they're separated by a distance, right? So that's your radius, that's R. And they want to know, well, what is the electrostatic force that these 2 electrons experience, right? Because these 2 electrons hate each other. They don't want to be anywhere near each other, and they're applying a force, an electrostatic force, to push each other away. So what is the magnitude of that force? How much do they want to push each other away? So what you do is you figure out what your nodes are. The electric charge of one electron is negative 1.6 times 10 to the negative 19. We learned about this a few days ago. That's how much one electric charge is. Either one proton or one electron. So all you do at that point is you plug in all your nodes into this formula. So you plug your nodes into this electrostatic force formula. Then what you do here, after you plugged in everything, you multiply the top part of your substitution, right? You multiply that entire top part, you get 2.3 times 10 to the negative 28. What you do after is you square your denominator, and then you get the number over there. And then you basically divide 2.3, the numerator, by the denominator, and you get your answer. All right. Any questions about that? If you want to, you can, but you don't need to, because you can actually do it in your head. So, I mean, if you want to. Yeah, answer on the bottom, you can Google, put that into Google. Make sure you put the parentheses. Guys, you can do this on any calculator. Even your phone supports it. You just gotta like do this the side way. Okay. You want me to go over number 2? Can someone tell me my notes for number 2 on Go Forward Lift?
K is 9 times 10 to the 9th.
All right. K is 9 times 10 to the 9.
R is 0.050.
All right. R is 0.050.
And Q2 and Q1 are 6.4 times 10 to the negative 19.
Good. So Q1 and Q2, right? Because it says 2 Coulomb point charges, 2 positive 6.4 times 10 to the negative 19 coulombs. And what are you trying to find out?
Fe.
Yeah, you're trying to find out where the electrostatic forces between these two objects. So you're just going to plug it into a calculator. I mean, plug it into a formula. So this becomes K is 9 times 10 to the 9. R is plus 6.4 times 10 to the negative 19. 6.4 times 10 to the negative 19. Square root of 5. I'm sorry, I keep saying square root for some reason. And we're gonna do the top part first. We're gonna multiply the entire numerator first. So we're gonna multiply that first. So we'll multiply the entire thing. Plug it onto a calculator. We get 3.7 times 10 to the negative 27. 0.05 squared. So you can do the bottom now if you want to. So you're gonna square the 0.05. And if you plug that into a calculator, you're gonna get 0.0025. Square that. 0.0025. And you do this. 3.7 times 10 to the negative 27 divided by 0.0025. And you get like 1.48 times 10 to the negative 24 newtons. All right. So basically, you're just plugging everything into Google, right? If you don't want to separate your exponents and then multiply them, if you want to just put it into Google, you can just do it. It's really up to you. It's really up to you. I hope you do. I hope you do. Oh man. Yeah, just a minute after you're done. Guys, have a great day. If you didn't finish your homework, you can finish it today. I moved the due date to today. So yeah, making sure you submit the Google Go formative. It's going to be treated as classwork. All right. I don't care if you get it wrong. Doesn't really matter to me. I do want to see work though. All right, guys. Have a great day. See you guys tomorrow.
Mr. Chan, I have a question.
Yeah, I'm gonna answer.
We need to copy everything in the Go formative.
Yeah, if you want to take a picture of your work, you can. If you want to upload your work, you can as well. Yeah.
Oh, okay.
Don't take a picture of my work. Okay? Yeah, don't take a picture of my work.
Okay.
Yeah.
Okay, bye. Have a good day.
You too, you too.